طيب في أي سؤال على المحاضرة اللي طافت؟ Announcement, late policy, first 5 minutes free, second 5 minutes every 4. السيستم يقول كل 3 تأخيرات بغياب، أنا خليتها 4. طيب lowest quiz will drop it. يجي متأخر يحضر نهاية الكلاس. طيب الله يسعدك. Okay. So last time we talked about the logic or the symmetry between voltage and the pressure. And we said the voltage you need 2 points, تمام? And we said the current is like the flow. And you only need a probe to measure the flow. تمام? And we said the higher the resistive the element, if we put 2 pipelines, this is a pipeline of width 4, more resistive means very narrow, lower resistance means wider, the flow will be the same. Why? Because they are in series. What will matter is the voltage drop or the pressure between the beginning and the end of each element. Okay? Keep it that simple for now. Once you solve more problems, you will be able to figure out what we mean by that, okay? So electric circuits. We represent electric circuits in general using these diagrams. You're already familiar with this. You took it in Physics 102. You took it in, I think all of you took it in Physics 102, right? So this is a voltage source, resistor, capacitor, inductor. We'll talk about them later. Now, what matters to us is voltage sources, they create forces. If we remove all the voltage sources and we connect resistors and capacitors next to each other, nothing will happen. So the means of energy, we need to transfer this energy to either resistors, inductors, capacitors. These 2 are capacitors, these 2 are inductors, and these are resistors. You will see them in the lab, unless you are in space or software. Talk to me, I'll show you those elements in the lab. I can give you a tour if you want. So as a result, energy is transferred from electricity to resistors. Think of the lamps as resistors, and we get the work done by transferring the energy elements to those elements. So we call every one of those elements. In the exam, if you see, for example, a circuit and you see a box like that, it means an element that we don't know what it is. If you open the problems, you will see we call this element A, for example. So element A can be a resistor, can be an inductor, a capacitor, can be an inductor, can be a motor, can be any other element, okay? We don't care if we put it as a square. Get it?
Can it be a battery? Can it be a battery?
No. A battery or voltage source should be a known element because it transfers the energy. But in the exam, if we show you the boxes, it means it's an element we don't care about. It either absorbs or delivers energy. Well, it can be a battery, but let's keep it simple for now, okay?
So it only absorbs energy?
No, not necessarily. We'll show the examples depending on the sign of the energy. So as a result, energy is transferred between the circuit elements from, in this example, from the battery to all the other elements. Get it? Okay? Now, one more time is we have those dark lines are copper. Okay? Conductors. These are conductors until you reach the element. And the element is made of whatever component is made of. Now, in order for the current to flow, it needs to leave this point, the plus sign, and it goes through a journey, and then it has to go back at the end. If we cut the cable or open the breaker, if we have a breaker, then the electricity will not move in the circuit. Okay? Any question about slide 15? So, current, talked about that last time, except the last time I forgot to mention that electric current is the flow of the positive electrons, not the negative electrons. It's irrelevant to this course. We don't care about it. And the charge of electron is minus 1.6 times 10 to minus 19 coulomb. So as you can see, the reference direction of the current I, it goes with the flow of the positive electrons. The last lecture I said it's the negative. I was wrong. I made a mistake. Okay? So I of t is the rate of change of the charge with respect to time. The more columns moving from right to left, or holes, we call them holes from left to right, the more current will go through. Okay? So you fix the time and you count how many charges will go. This is a physics level, not engineering level. But in engineering level, we care about the concept, so we all agree that the current moves through the conductor in the direction of positive electrons. Of course, if you make this cross-sectional area of the conductor larger, you will be able to accommodate more electrons flowing in the conductor. Now the conductor it has a negligible resistance, so you do not need to count the voltage drop in the conductor. So I'm going to give you a simple example. We call it example 0, okay? I have a battery, and then I put a conductor. What will happen if I connect the positive or the negative to the battery? It will damage the battery. صح? You get so much heat if you connect the positive, and then ultimately the battery will die. It's short circuit. And we cannot know how much current is flowing here because it's so much. The resistance here is almost equal to 0.0000 whatever ohm. Ultimately, the current will go through, so there is no resistive path. ما في معاوقة if you connect a short circuit. So the current will go from the positive, we call it I, and then because the resistance is so small, the battery will drain itself until it dies, and then there is no more electricity in your system. So conductors, in this course, the resistance of a conductor is just 0. Okay? So going back to the previous element, you do not count the resistance of the copper, but you count the resistance of the resistance of the inductor, the resistor, or the impedance we'll talk about later of the capacitor and the inductor.
What about the internal resistance in the battery?
Ignore it. Of course we ignore it. Okay? Becomes a matter if you do generator design, the internal resistance matters. But for our course, we will ignore it. Maybe later it will show up, but it's beyond the scope of this course. But usually they represent the battery with an equivalent model of another battery and a simple resistor. And this box, same as this box. In this course, we'll deal only with this. Get it? Any question about it? Okay, when محل? Okay. So let's solve a simple example from the book. And if you want me to solve the example on the board, tell me. Don't feel shy, okay? Sometimes I solve examples by looking at the slides, but if you want me to solve it, raise your hand and I will solve it, okay? Let's look at the first simple example. A constant current of 2 amps flows through a circuit element in 10 seconds. How much net charge passes through the element? So you can use your imagination. We call this an element, and then we say a 2 amps is moving through the element. In 10 seconds, you have 2 amps, and we say amp is coulomb per second, right? So in 2 seconds, if you multiply by 2 seconds, you multiply by 2 seconds here,
10 seconds.
well, 10 seconds. Then the second and second will cancel, and you will have 20 columns. Easy? It will not come in the test, okay? Because it's an easy problem. The second problem, it tells you, no, this is not a constant current. So this current is constant all the time, it's 2 amps. What if we change it to a mathematical expression and we represent it by little I, means current, we put a bracket and then we put T, indicating it's a function of time. And then what's the amplitude? 2. Get it? Times cosine of. Now, cosine is a trigonometric function, math 002, and then it's 200 times the time. Okay? Now this 200 times t is an angle. So if we plot in the time here, so if you want to calculate I at 5 seconds, it will be 2 times cosine 200 times 5, and then you do the math. I don't know what it is. But in this problem, it tells you, okay, we want to take the derivative. So we say,
The function is different.
oh no, sorry, that's it, the Q, right?
هذا الإجابة.
هذا الإجابة. Okay, the charge Q of T is 0.01 sine, I think it's 200 T. Now if you take the derivative, dq with respect to dt, it will be 200 times minus 0.01. I think there's a negative sign. اشتقت الساين cosine, ما في negative, times cosine of 200 t, and then you will get I of t. Now sometimes the trick in the exam, we give you a harder mathematical function. Okay, what if I give you a sine? Then it's minus cosine. What if I give you sine squared? Go back to 002, and that's the trick. So trick in the exam is make sure you understand the basic derivative. So maybe derivative of sine squared, maybe it will come in the test, maybe the derivative of sine times cosine. Remember those, right? But we will not give you very hard. Maybe the hardest thing we'll give you is maybe, okay, if this is cosine, you give you the test sign. And then the trick is you don't forget the minus sign. Any question about these two simple exercises?
Here the current is alternating from positive to negative.
Yes. So how are we going to draw this current that we just found? Well, it's very simple. This is T. What's the units? Don't forget the units. Seconds. And what is I? What's the unit of I of little t? In amps, ampere. Okay, don't forget the units. We'll take off points if you forget the units, but it's MCQ, so it doesn't matter. Okay? But in the quiz, if it's written, don't forget the units. In the homework and the quiz. Okay? So what's the amplitude is 2. 2 minus 2, and then you draw. It's a cosine, so it will begin here. Or ask ChatGPT to draw it for you. Okay? As a matter of fact, the 200, the number 200 times t, you have to understand when this is equal to pi over 2. Okay? And then you will find the time that it reaches pi over 2, which is the zero cross-section area. So the time you find is the one. Once you find this time, you can plot the signal, and then you equate another method of drawing it. You say 200t equals to pi, and you know where is the pi, which is here. And then you know what is the 2 pi. You solve for 3 times, then you will be able to draw your signal without using a computer. Okay? And this is another trick that I want you guys to understand is what if we ask you, what if we gave you 4 different graphs of the answer? So you need to understand which one is cosine, which one is sine. Now we'll talk about this later, but for now what matters is the concept which is taking the derivative of charge. But again, this is not electrical engineering, this is physics. Get it? Understand? Any question? Now they want you to give what we call it a piecewise function. A piecewise function is a function that has two different times. So at time less than 0, for example here the charge is 0. Okay? What's the other definition of time is Q of t is 2 minus 2 e minus 100 or 10 or 100? 100t. And don't forget the unit, column for t greater than 0. So if you take the derivative, if this is a piecewise function, the derivative is also a piecewise function. What's the derivative of 0? 0. What's the derivative of this?
208 to the negative 2.
Well, the derivative of the DC part is 2 minus 2. So we take minus 100 times minus 2 is 200 plus minus will cancel with the minus times the exponential. Exponential is the easiest function to take derivative of integral. And what's the unit? Or t larger than 0. I can't put equal, it doesn't matter. Actually, we're missing the definition at time of 0. It's a mistake in the book. But yeah, at time 0, it's... So you can see that's how you write your answer. And I think you should put an equal sign here. These problems happen if you try to write a code and you forget to define it as 0, then your code will run into error. So always be consistent. Always be consistent. So any question about this example? Okay. Okay, let's take a quick look at the old exams. I'm going to show you how أحرق عليكم الأسئلة. That's okay. This is one of the midterms, and I remember I was looking at those exams, and then so you can see we don't have any question about. Okay, here no, it's not that one. I think it's the last one. Do they have? I think I saw one for part. Okay, anyway, it doesn't matter. Actually, it's one of the old exams. There was a question that tells you, oh, the rate of change of color of the charge per time is called electric field, electric current. The answer is electric current. So sometimes we'll ask you questions in the test about the actual concept, the rate of change of the charge per time. Okay? Now, if you want to plot the signal, you can plot it this way. As you can see, over time the charge would accumulate because we're pushing charges. We're counting how many positive electrons going through, and then they accumulate over time, but the electric current decays over time if we write this function. So this is an exponential decaying function, okay? Because it has e to the power minus 100t, it's decaying exponentially, okay? Any question about how to find this drawing? Again, if you don't know how to draw it, if you see different figures in the test, just substitute sample numbers. So for example, substitute, okay, you see this is 100, maybe at 10, substitute at 10, see if it matches the values here, and then you will know at different points. This is one of the techniques. So you don't have to derive everything. Maybe at time 0, you put 0, it's 200. At time 40, try to put at time 40. Remember, this is a millisecond. So 40 milliseconds is what? 40 times 10 to minus 3. You plug this number, you put it into this function, and then you will find a value very close to 0. This is one quick way to pick out which curve is the right one. So any question about the plot?
Using the calculators allowed?
I think calculators are allowed, of course. But we will have usually limited time, so if you try to plot the function, you can plot it. Yes?
Can't we plot the starting value of I if we want to see at for example at what is the lowest value of the current related to time, we can equate it to 0 and then
Yeah, but this will never reach 0.
when we do length
Until you put 1 million, even try time 1 million seconds.
Yes, but at infinity, so we know that.
Yeah, you do these 102 tricks. I don't know, I forgot the one. I don't care about it. I want you to know the concept. If I give you certain figures, I want you to pick up the right one. So maybe one of the choices will give you a figure that looks like that. We'll give you a figure that looks like that. We'll give you a figure that looks like that. And I tell you it's E minus T, so you eliminate this. There is no DC shift, so you eliminate that, and then you pick up this one. That's a simple question. Okay? This is how MCQ, I'm training you to solve MCQ problems, okay? Because we want to get the highest average, section 2 and section 4. You want section 1 and section 3. Beat us, okay? And by the way, we are 2 full sections. So, it's 2 full sections, so please don't disappoint me. Now, if I bring an oscilloscope and I take the signal from here, it's going to look like a sinusoidal signal, okay? A sinusoidal signal. So AC current, as you can see, it changes over time. DC current, it's flat over time. هذه نسميها بطاريات, هذه نسميها voltage source. Okay? The electricity that we use in all the buildings is AC. The electricity that's in computers, phones, etc., that's DC. That powers up the phone, DC. There is a debate about AC and DC, which one is fine. Now we have even mix and match, but the concept here is if it's flat over time, I want you to learn this important concept is inductors and capacitors, they cannot work with AC, with DC, they only work with AC. Why? Because capacitors and inductors, they are nonlinear elements, and DC exhibits linear behavior. So this one only deals with resistors. Can you operate an electric motor using DC?
Yes.
Yes, because there is a DC motor. Can you operate a fan in our buildings using AC?
No.
No, because it's an induction machine. Now, you have to read the specification of every computer, of every device. They will always tell you whether you need DC or AC. الشاحن حق الايفون, it accepts AC, and then it has a rectifier, and then it becomes DC. So your phone actually sees a DC, but the other side of the charger sees what we call it an AC signal. Okay? Now, another convention. If I have a capacitor, a resistor, okay, and I call this point A, and I call this point B, okay, we always put the value of the resistor, and always, as a beginner, put all the units. The unit is between brackets, it's ohm, okay? So if I say the current I of T, because we are lazy, I can say on the drawings, I can drop the T, I can call it I. Get it? Because we are lazy. Okay? You don't want to have lots of T's in your circuits. When do you put the T? If you deal with mathematical equations. On the schematic, drop the T. And I say, and I always put IAB, which means the current that moves from A to B. This implies the current that moves from B to A is actually the negative of the current that moves from A to B. Get it? Understand? Whenever you see a circuit, you have to be organized. Okay? From A to B, is negative, or from B to A. This is the whole slide. For the voltage happens because the electric charges, the pluses and the minus, are separated. They create a potential. It's like the water dam. Work or energy must be due to separate positive and negative charges. So voltage is the energy per unit charge created by the separation, energy transfer per unit charge that flows through the element, which is the rate of change of energy over the charge. So it has the unit of joules per coulombs. Okay? What's the unit of energy? Joules. What's the unit of charge? Coulomb. So the rate of change is the volt. Potential difference equals to volt. Okay? Now how we represent it with these elements? Again, let's bring the resistor. Put the two circuits. Call this A, call this B. This is a resistor. Has a unit of ohm. What did I tell you at the beginning? To measure the voltage, you need 2 points. So I need to measure the voltage of A minus the voltage of B. I'm going to repeat this concept. I'm taking two props, VA, VB. In reality, we're doing the difference. That's the actual definition. It's a potential difference. فرق الجهد. Difference means طرح. VA minus VB. When I write it down, I have to say it's VAB, indicating it's VA minus VB, because we are lazy. So we are lazy when it comes to current, we drop the time. Same for the voltage, we drop the time, but also we say VA minus VB, which is the potential difference. Now, VA minus VB, I put the plus here, I put the minus here. It means I'm taking VA minus VB. It's like the pressure, you need two elements. This implies it's equal to minus VBA. If I put the element, this is B, this is A. If I put the plus here and the minus here, that voltage, VB minus VA, is actually negative of that. Clear? Now, في الاختبار يا شباب. علشان once we solve our problems, we'll get it. Sometimes you will find the signs as given to you. إذا الإشارة أعطاك إياها خليها لا تغيرها. إذا الإشارة ما أعطاك إياها أنت تحط وتمشي عليها. فهمتوا؟ I will show it in an example. Okay. So any question about this slide?
Question.
Yes.
About the previous. What's the difference between voltage and current?
It's like the difference between the pressure and the flow. فرق الجهد, it tells me there is so much charges at point A willing to go to point B if the voltage is positive. If the voltage is negative, there is more charges so there is more positives going to B. The more of the charges are willing to jump, the higher the voltage, which is like the pressure. The flow of the current tells you how much actual electrons are moving through this pipeline or through this resistor. So that's the difference.
So here in the definition of voltage, we said that it's D of energy by D of charge.
Yeah, you can't visualize it. It's hard to imagine.
What do you mean by energy?
طاقة, joule, which is the power over time. We'll see an example. Energy هي الطاقة.
Yes, I know what the translation of energy.
Mm-hmm.
So what do
So
you mean by
the energy is how much. If you have a big battery, it has a high energy. It has so much electrons inside it. Smaller energy, very small electrons inside it.
So it's related to the number of charges.
Yes. But think of it as big water dam. It has so much energy because it has so much water.
Okay.
Small water dam has a little bit of water. It doesn't have much energy. Now, every hour, how much power is generated per hour, energy transferred per hour, it is another definition. It's like زي محرك السيارة. If it's محرك السيارة has to do with the power, but for electricity, think of it as it has so much chemicals that are willing to produce electrons. It has so much chemicals willing to produce electrons. It has so much photons for solar cell willing to produce electrons. It has so much mechanical movement willing to generate electricity. So it tells you how much energy. Now how much energy? The rate of change of the energy per the charge defines the voltage. So the voltage is measured between 2 points. Current is measured through the element. So any question about this? Yes.
Is there a relation between direction of current and direction of voltage?
No, they are two independent. The direction of the current, we said, is the direction of the positive electrons. The direction of the voltage is you're measuring the pressure. Have you ever heard about the negative pressure?
Negative pressure?
Vacuum? In mechanical? So in electrical engineering, we don't have vacuum, but negative pressure is electrons are willing to go through the other direction. Now, we finished 1.3, 1.2. Any questions about 1.2? Now, power and energy. Power is, I told you last time, the product of the current times the voltage is the power. And we all know energy is the integration of the power. If you play with the unit, volts times amps. Volts is what? Joules over coulomb. Amps is coulomb per second. Then you will get joules per second, which is the watt. Okay? You can also transfer the watt to horsepower. But in electrical engineering, we don't use horsepower for electric systems except one element, which is the generator or the motor, because it's linked between the mechanical system and the electrical system. Now, energy in a typical element, V times I equals to the power. If I reverse the direction of the current, if let's say this element what if I say this element, which can be a resistor, and I put the element going from I, B to A. So the power is actually VAB times IBA, which is equal to VAB times minus IAB. صح? So this implies the power from B to A equal to the negative of the power from A to B. So if you reverse the direction of the current, you will reverse the sign of the power. And this is very important when it comes to absorb or consume or deliver. Yes?
Why you took the voltage AB not the BA?
It doesn't matter. I'm calculating this quantity. Yeah, you're right. Well, if I took VBA, then they will be equal. So, if you do VBA times minus IAB, then they will be equal. But I'm just telling you, what if I calculate VAB and I reverse just the current? If I reverse the voltage and the current, we will have the same power. If I reverse the voltage and keep the current from top to the bottom, then I'll have the negative of the power. Now, depending on the combination of the problem, you can define the power. Okay? So we have 4 different combinations, okay? Per element, you have 4 different powers. Now, to get the energy, once you calculate the mathematical expression for the power, you can take the integration. Now, here is a very important slide. This slide is probably the most important one. If the current, we said the current is the positive charges, moves from the positive polarity through element toward the negative polarity of the element, absorbs energy. You gain. The element gains energy, and think of it as a lamp. If the current moves from the negative polarity towards the positive polarity, the element supplies the energy, and this is a loss, and this is a negative energy. Let's represent it in a capacitor. So, let's say we fix the voltage, plus, minus, and we call this VAB. If the current IAB, which moves from positive to negative, then the power is VAB times IAB. If you write this equation, do not put a negative at the beginning. This is option 1. Option 2, if I have negative and positive, and we call this VBA, صح? And then I have IBA, which moves from top to bottom. What's the power? VBA times IBA. Are they the same? Yes, they have the same sign. If it enters through the positive, heading to the negative, do not add sign in the equation for the power. If I play games and I do option 3 and 4, so option 3, we have A, B. If I have plus and minus, let's say I have BAB, and I put the current, IBA. Then I have to add a negative sign. Okay?
Option 3 and 4 will be the same.
Option 3 and 4 will be the negative of 1 and 2. Okay? Now, this P is same as this P. Okay? So that's why I need to put a sign, and then I keep VAB times IBA. Option 4, it's very clear. Keep the negative sign, VBA times IAB. Either can it enters from the negative, it's option 3 and 4. Option 1 and 2 is the standard. Now, this P, لو كانت هذه 5 watt, this quantity is going to be minus 5. Minus 5 times minus 5 is going to be plus 5. Ultimately, the power has to be the same. This is what we call the passive reference configuration. If the current enters from the positive, we don't put the minus. If the current enters from the negative, we put the minus. We will solve problems. I'll explain it better in a problem. But keep in mind option 1, 2, 3, and 4. Most likely, we love dealing with option 1 because it makes more sense. Okay? Unless he tells you in the problem, reverse the polarity, then we will have other combinations. Now, if the energy is absorbed by the element, if the power is positive, means absorbed. If the power is negative, means supply. Okay? Let's do this example. Now, I want to ask you, what is this option? The first problem. You get VA, we call this VA, which is VA to B. I'm being more consistent, VA to B, which is, they can call it sometimes VA. Now, another thing, they call it VA, if they don't want to name the B, they drop the B, they just keep the A, then they call it VA, the book. I personally like VAB, okay? What is this option? 1. What is this option?
2.
What is this option? No, is this option 2? No, that's option 3. What is this option? 2. Again.
2.
This is option 1. So 12 times 2 is 24. Okay? This is option
3.
This is option 3. So we need to put the negative. And then you put 12 times 1. What is this option? 2. The negative is already in the current. So we don't put the negative sign at the beginning. This negative sign at the beginning comes with options 3 and 4. Okay? And then positive absorb, negative supply, negative supply. Anybody doesn't understand this example? Please raise your hand if you don't understand. I would rather waste the lecture in explaining this concept. How many options I told you we have? 4. Option 1, البوزيتيف والكرنت يدخل مع الموجب. Option 1 هذا كلاسيكي. تقلبهم كلهم option 2 ما تحط نيجاتيف ساين. تقلب واحد منهم تحط نيجاتيف ساين. فهمتوا؟ هنا في الاوبشن 1 واوبشن 2 خليناهم زي ما هم 12 times minus 3 12 times 2. في اوبشن 2 حطينا النيجاتيف غصب لاننا اوبشن 3 and 4. Get it؟ واضحة؟ Now 24 absorb or supply? Absorb. Minus 12 absorb or supply? Supply negative يعطي زي رصيد البنك. إذا رصيدك سالب لا. إذا رصيدك سالب يعني أعطيت، ذكروها كذا. نيجاتيف 36 رصيدك سالب أنت أعطيت 24 ستيتمنت 24 أنت تاخذ 24. أوكي؟ بوزيتيف أبزورب زي اللمبة أبزورب، نيجاتيف زي الكاباسيتر يخزن، سبلاي، كاباسيتر زي البطارية يعطيك. أوكي. This is a mathematical problem. Again, the current enters from the positive. Are we doing option 1, option 2, option 3, option 4? Classic, option 1, so no negative sign. So what is the power? 12 times 2e minus t. 12 times 2e minus t. إذا قلبت the current, I have to put a minus sign. If I don't flip the current, so the best thing, deal with the options, okay? I want you to memorize all the options. Now you do the energy, you integrate 24e minus t. If you do the integral from 0 to infinity, you will do 24, which is, this is 0, minus 24, it will be 24 joule. So because this is 24 joule, then the energy is absorbed. Now the power is absorbed, but also the energy. So any question about this problem, 1.3? Anybody knows how to do the integration?
السؤال اللي قبله بس بالنسبة للباور عادي أحل الحل كامل بدون ما أضيف علامات مثلا وبالنهاية بس أحط indication إذا كان absorb ولا loss.
No, because the passive sign reference convention الاتفاق حقنا إذا هي option 1 and option 2 ما تحط negative. إذا هي option 3 أو option 4 غصب تحط negative. بعد ما تسوي الحسابات إذا هي موجب absorb، إذا هي سالب supply. ما لازم تتأكد أنت في أي option شغال. إذا أنت شغال في option 3 and 4 لازم تحط سالب غصب. إذا أنت شغال في الأوبشن 1 and 2 ما تحط سالب. في النهاية حسب الجواب، يعني عندك كذا مثلا أوبشن 2 كان الجواب نيجاتيف بس ما حطينا سالب. أوبشن 2. واضح يا شباب؟ في الامتحان it's better to keep this, call it طبعا this is called VB, indicating element B. But if you find يعني two notes that has letters, keep the letters the way I did it. تمام؟ Let's solve example number 3. Compute the power as a function of time for each of the elements shown in figure 1.17. Find the energy transferred later. Find the energy means integral from 0 to 10. But first, before that, we need to do what's the power. What's the power here? What option is this? Classic, option 1. Do we put a negative sign? No, we don't. So what is I of A? I of A is I of A is 2t. So let's try to solve it. So we have option 1. Option 1. You have to say the word option 1. Okay. So the power is V times I. No negative sign. So the power is what? 2t times 10t. So 10t times 2t, which is 20t squared, صح?
Yes.
What's the unit? Watt. Now we don't know, most likely this is a positive. So this will never be a negative, so we know it's absorbed. If you do the integral, then you do the integration of 20t squared from 0 to 10, which is going to be 20 over 3t cubed. You do from 0 to 10, which is 20 over 3 times alpha. I think so. You are 20 على 3, you do the math. What's the unit? Joule. This is a positive. 6650 positive. So, because it's a positive, for AC voltage and current, check the sign of energy inside the element absorbable. So this element is clearly absorbed. You also could have known it from the power. Now, what option is that?
3.
Option 3. خلي the current enters through the negative. Okay? Well, option 3 and options 3 and 4 إذا ما عكستهم كلهم, well, this option 3 and 4 يعني واحد عكس الثاني, you always have to negative. This option 4 اللي هو option 4 اللي هو كذا, the current من فوق والفولتج مقلوب. طبعا if you have a horizontal element this becomes complicated. For horizontal elements option 3 and 4 are the same except right to left. Now the moment you see the current enters through the negative, put a negative sign. تمام? So this is option 3 and 4, but in our convention this is option 3, so we need to add the negative sign at the beginning. شوفونها? It's negative sign. V times IT and then V times I, and then if you do the multiplication you have a different. And this element supply or absorb? Supply. Okay, is this example clear?
Yes.
Okay. Let's see if there's a relevant problem. We don't have it. Okay, doesn't matter. In the next lecture, we will cover the KCL. I don't think we have enough time to cover the KCL. I was hoping to cover at least the KCL. But I wanted to rewatch the lecture on YouTube. I'll stop the recording. Any question before we end?